Hello, this paper introduces a test time framework to improve the generated images via diffusion models in two aspects: semantic alignment with the textual prompt and visual alignment with user preferences. Let us start with a quick overview of how text-to-image diffusion models like Stable Diffusion work. First, sampling the random Gaussian noise. Then, using a U-net to gradually denoise the latent over time steps. Finally, we decode the clean latent into a clean image. While powerful, these models often fail to align well with human intent. These examples show that although the images are visually appealing, key elements from the prompt are often missing, like apples, sunglasses, waves, or lighting effects. This highlights the misalignment between the generated content and both the textual prompt and user preferences. Our goal is to bridge this gap. We aim to generate images that not only align with the given prompt but also faithfully reflect user intentions, including content, composition, and style. This is what our method targets. Previous training-based alignment works, like Diffusion DPO, rely on supervised fine-tuning with datasets of preferred image pairs. And some methods use reinforcement learning to update the diffusion model using a pre-trained human preference model. However, these methods are resource-intensive and lacks generalization across diverse preferences. In contrast, training-free methods use pre-trained preference models to guide the generation process. However, full-chain backpropagation is time-consuming, and one-step approximations often yield blurry images, leading to inaccurate guidance, especially in early steps. To address issues above, we propose a test-time alignment method. Relying on the pre-trained differentiable text-aware preference scores of the one-step predictions, we guide the denoising process with the gradient computed for the intermediate noisy images. However, one-step predictions prioritize efficiency but fail to capture detailed semantics in early-stage noisy images, limiting the effectiveness of textual alignment in preference-based guidance. Based on a discovery that the text-image attention maps indirectly reflect semantic contents, including entities and layout, we design a semantic alignment objective to minimize the discrepancies between the attention-based contents and LLM-extracted text semantics. Then we dynamically schedule two objectives for tailored guidance across time steps, generating detailed content while keeping the layout. We further propose a dynamic recurrent strategy to adaptively decide iteration count at different stages for improved guidance. Compared to baseline Stable Diffusion, our method preserves layout and improves visual fidelity in a sample of a frog holding an apple. We prevent poor early-stage guidance by better supervising the intermediate steps. In another example, our method generates a polar bear cub wearing sunglasses in a flower field. Unlike the baseline, we capture both the object and its attributes accurately, thanks to our semantic and preference alignment design. Here are more examples based on Stable Diffusion. You can see how our method improves not only the alignment with the prompt but also aesthetic quality, lighting, and structure of generated images. Our method also works well with SDXL-based models. It enhances details like texture, color vibrancy, and clarity. Our approach is architecture agnostic and boosts output across various backbones.